Hi everybody, Unit 1 is complete, so I thought I'd go back and do Lab 2, Civilization, to show you guys my thought process, and it'll maybe clarify some things and answer some questions that you may have had when you're going through the first couple of labs. So we can get right into it. The first question on Lab 2 was estimate the power of a bulb. So I like big round numbers, so I estimated at 100 watts. So the first thing you should do in these labs or the assignments is when you see a unit, you should always try to remember what that unit represents. So for watts, remember this is a unit of power, which is energy over time. And the unit of energy that we use in physics is joules. So watt is equal to a joule per second. So there you go. So that's important to remember. The next question of this assignment asks for seconds in a year. So some of you can do this really quickly on the calculator, but if you want to be really clear about it, you can use the unit conversion method, which I went over in a previous video, but we can quickly do that here. So I just like to go from left to right. So there's 60 minutes in 1 hour. And then you know that there's 60 seconds in 1 minute. And you can already see that these are going to cancel because the minute unit is on the bottom and the top of our fractions now, so they can cancel. And then we can do this real quick. 60 times 60 is 3,600. And that's seconds over hour. So we know that there's 3,600 seconds in every hour. But we want to know how many seconds are in a whole year. So then we can do 3,600 seconds per hour. And we know there's 24 hours in 1 day. And finally, we know there's 365 days in 1 year. Well, look at that. So we've set our units up so that we can easily cancel them out now. Hours down here, hours up there, they cancel. Days down here, days up there, and we're left with seconds per year. So that's the beauty of unit conversion. Now you can just times together all of the numbers on the top of our fraction here in the numerators, and then all the numbers in the denominators. And the multiplication in our denominators are pretty easy because they're all ones. So it's 3,600 times 24 times 365. So I'll break out the calculator for this one. So it's okay if you want to use your calculator for maybe one of the first calculations in the labs. Usually you break out your calculator once, but once you get that number, then you can round it off and use estimations and just do it in your head the rest of the time. So I'll explain how I'm going to do that. But let's do 3,600 times 24 times 365. And I get 31,536,000. And so I'm going to round that down to just 31 million. 31 million. And so 31 million is a 31 with 6 zeros after it. So we like to simplify things even further. We could put that into scientific notation. And remember in the labs, you simplify things to scientific notation. Instead of doing 31 times 10 to the 6, you actually want to write 31e6. So that's how you represent 31 million. And remember, right now we have seconds per year. Okay? So let's clear up some space. So we have 31e6 seconds per year. The next question is calculate the energy that a light bulb uses in a year. So remember, we have watts, which is joules per second, and now we know how many seconds are in a year. So it's yet another unit conversion. So you can do times 100. Remember, 100 watts is 100 joules per every second. Guess what? Seconds cancel out, and we're left with joules per year. And then we do 31 million times 100, and 100 can be represented by 10 times 10, or 10 to the 2, and that can be represented further, which is equal to 1e2. So go check out Professor Timmy's math review, because he talks about multiplication of exponents. But if you already know this, you'll know that 31 million times 100 can be simplified to 31e8 joules per every year. Okay, the next question is, how much energy does a household use in a year? And the hint given here was assume that the household has 100 light bulbs. So 31e8 joules per year for one light bulb. Well, guess what? We times this by 100. And there's no unit here. We're just multiplying the energy output for a whole year for one light bulb by 100. So this is the same thing. Remember, 100 is 10 to the second power. You do your exponent multiplication, and 31e8 becomes 31e10. So this 8 is just added by 2. So I hope that's clear. And so then the average, or the estimated energy output of a household now, we're calling 31e10 joules per year. And finally, okay, so we have 31e10 joules per year. The last question, what's the estimated energy output for civilization? And the hint there is that estimate there's 1 billion households. So 1 billion is 10 to the 9th power. So now we're timesing this by 1e9, or 10 to the 9th. And it's the same thing. We're taking our exponent 9 and adding it to the exponent that we have over here. And so this becomes 31e19 joules per year. Wow, I wrote that terribly. There we go. So I hope that clears up some things, guys. I'm going to take a look. I mean, I've already looked over the labs, but I'd like to make another video to go over the labs in Unit 2, maybe find some things that you guys will probably get stumped on, so I can help you there. So I hope this helped. As always, ask in the hallway conversations, or you can comment on YouTube if you have any questions at all. Good luck, and I'll see you online.